Welcome to solverfy.
Given the sample of 100 bank customer waiting times, and you're given that the mean is 6.022 minutes of waiting and the standard deviation 2.616. Now for part B, we need to complete the table. The first is x bar plus or minus the standard deviation. So that would be 6.022 minus 2.616, which is 3.406, to an upper boundary from adding 8.638. And then two standard deviations would be 6.022 minus 2 times 2.616, which is 0.790, and an upper boundary of 11.254. And finally, 3 standard deviations for 99.73% of all possible bank times is negative 1.826. And the upper boundary would be 13.870. Does the estimate of a tolerance interval containing 68.26% of all waiting times provide evidence that at least 2/3 of all customers will have to wait less than 9 minutes for service? And we should say yes, because the upper limit of the 68.26% interval is 8.638 minutes. Actually, that wouldn't be, which would be less than. That's probably your option. 9 minutes. How do the percentages of the 100 waiting times that actually fall into the intervals compare to those given by the empirical rule? And for part D, if you look at the 100 pieces of data and count them up that fit into the first interval, 70% fall into x bar plus or minus 1 standard deviation, 92% fall within 2 standard deviations, and 100% fall within 3 standard deviations. I'm not sure your options are for the last 2, but it does seem reasonably valid for the, that's very close to 68.26%, 95.44, and 99.73.